sun flickered once. And in that instant, something ancient stepped out of its glare. 3IATLAS, a traveler from another star, returned not as a dying comet, but as something far stranger. Its light pulsed like a heartbeat, its tail moved with purpose, and its geometry revealed patterns that no natural object should possess. Instruments around the world went silent, as if ordered to stop listening, just as the sun itself answered with a synchronized flare. Every reading, every frame, every missing second pointed toward a connection that science could not explain. Was it coincidence, resonance, or something deliberate moving through the fabric of our solar system? The silence hides a message, and tonight we will trace it from the light that returned wrong to the moment the sun seemed to speak back. Something is happening out there, and it begins with what we were never meant to see. When 3IATLAS emerged from behind the sun, astronomers expected a fading ember, a quiet traveler returning to the cold. Instead, it came back brighter, sharper, and oddly alive. Its light curve did not rise smoothly, like a comet's reflection of sunlight. It pulsed. The readings from amateur observatories across Chile and Japan revealed irregular jumps in brightness, as if someone were turning a dial on and off. This was not noise. The fluctuations were timed too neatly, repeating at intervals that matched nothing in the models. Official statements called it instrumental variation. But the pattern persisted across multiple telescopes with different detectors. That kind of synchronization rarely happens by accident. It hinted at internal activity, a hidden rhythm beneath the surface. Some observers compared it to the blinking of a signal buoy at sea, marking position or intention. Others saw it as the flicker of outgassing jets firing in sequence, though no one could explain why they would pulse so precisely. The shape of the light itself was stranger still. Typical comets brighten as they approach the sun and then dim as they move away. But Atlas's luminosity dipped briefly and then rose again, almost as if it absorbed light instead of reflecting it. The graph looked less like a natural curve and more like a heartbeat on a monitor. Could it mean the object was responding to solar radiation in a way we had never observed before? Spectral readings showed uneven heating across its surface. One side glowed warmer, while the opposite remained cold. That imbalance caused some to wonder if Atlas was rotating in bursts rather than spinning smoothly. If it was tumbling, it should scatter light unpredictably, yet the intervals stayed exact. A body that brightens and dims at consistent times suggests a kind of rhythm, perhaps mechanical, perhaps chemical, but deliberate either way. Ground-based observers also noticed that Atlas was moving slower than predicted as it left the solar glare. Its path bent just slightly against the models. The deviation was small but measurable. Combined with the strange photometric pulse, it fueled speculation that we were seeing an object under unseen forces. Gravity alone did not seem to explain it. Some scientists proposed that solar radiation pressure was uneven, pushing on outgassed dust in complex ways. Others whispered about electromagnetic coupling with the solar wind. Yet, a third possibility emerged in private astronomy forums, that 3IATLAS was not a single solid body but a cluster of fragments orbiting a shared center, each reflecting light at alternating times. In that case, the flicker could be a rotating beacon pattern of multiple reflective surfaces. But if so, where were the expected debris trails? The data around those missing trails deepened the puzzle. Observers reported a clean, tight nucleus with no obvious fragmentation. That made the alternating light even harder to explain. Some compared the pattern to the periodic flashing of interplanetary satellites. But this was supposed to be a natural object from another star. If its light behaved like an engineered signal, then either nature had found a way to mimic technology, or technology had found a way to mimic nature. NASA's official logs for the solar and heliospheric observatory listed the re-emergence as nominal, yet no raw. imagery from that precise hour appeared in the public archive. Instead, analysts had to rely on partial sequences from amateur astronomers and deep sky trackers. Those images, though grainy, all confirmed one thing. The first visible glint from Atlas did not match the expected angle. It appeared offset, as if reflecting from a surface not facing the sun. For a brief moment, two separate observatories recorded twin reflections, one brighter, one dimmer. It was possible the dimmer one was a ghost artifact, but it lingered for several frames before fading. If that secondary light source was real, it could mean Atlas carried a companion piece, a fragment or body traveling in tandem. That would not be unprecedented. Some interstellar objects could split before entering a star system, but the synchronization of their brightness was uncanny. When one brightened, the other dimmed, like a binary pulse. This back and forth pattern continued for several minutes, suggesting interaction between the two. If they were fragments, they were communicating in the only language the cosmos understands: light. As the days passed, telescopes captured a new rhythm. The light curve stabilized, but subtle modulation persisted, faint yet deliberate. Researchers compared it to other interstellar visitors, such as Oumuamua, whose rotation had baffled scientists years earlier. Atlas seemed to be following in that tradition of anomalies, bodies that refused to behave like simple chunks of ice and rock. A physicist at an independent observatory proposed that Atlas might possess reflective layers beneath a thin crust, capable of refracting sunlight like a lens. If those layers were shifting or shedding gas pockets in bursts, the result could mimic controlled light pulses. But no known natural process produces that level of uniformity without mechanical influence. Each new observation deepened rather than resolved the mystery. The official reports remained sparse, while private data streams grew richer. Amateur astronomers shared their frames online, stitching together what they called the heartbeat of Atlas. In one composite, the light appeared to travel along its body from one end to the other, like a pulse of energy moving through a living organism. Skeptics warned against poetic interpretation, reminding viewers that comets often surprise with irregular activity. Yet even they struggled to explain why the brightness rose in precise intervals instead of chaotic flickers. When something behaves with rhythm, our minds search for intent. The re-emergence also coincided with a minor radio fluctuation detected by the Deep Space Network, lasting only seconds. The signal was dismissed as interference, but its timing aligned perfectly with Atlas's first photometric spike. Some theorists began linking the two events, suggesting that whatever caused the light pattern might also emit transient radio noise. Could 3IATLAS be more than a wandering fragment of another solar system? Could it carry magnetic fields strong enough to interact with the sun in rhythmic bursts, or was it a shell of metallic dust? Reflecting light in a pattern that mimicked intention, the public would never know for sure because the next scheduled observation window closed without explanation. When NASA's daily update resumed, Atlas's light curve appeared smoothed, as though the data had been averaged. The pulses were gone. In official channels, the anomaly never existed, but the independent observatories kept their unprocessed data. Their archives still show those living beats in the dark, that rising and falling light that refuses to fit the pattern of dust and gas. And so, when people speak now of the solar re-emergence of 3IATLAS, they talk about what was seen and what was not, a light that returned wrong, a rhythm that hinted at a secret, a message flickering across the void, then swallowed once more by the sun's glare. Because in astronomy, the most unsettling discoveries are not the ones we fail to detect. They are the ones that appear briefly, unmistakably, and then vanish, leaving only the echo of a pulse that should not have existed at all. When 3IATLAS came out from behind the sun, everyone expected a simple sight. a dusty glow, a soft reflection of the same pale blue hue comets usually display when sunlight scatters through gas and ice. But what astronomers found instead was silence in color. The spectrographs showed empty gaps where bright emission lines should have been. Cyanide, carbon dioxide, even water vapor. All the familiar signatures were strangely weak. It was as if the comet had stripped away its identity, becoming something neither dead nor alive, neither gas nor rock. At first, researchers blamed the sun's glare. The re-emergence occurred close to the solar limb, where scattered light can wash out detail. But the longer the observation continued, the more obvious it became that something else was happening. The missing color was not hidden. It was gone. Even after image correction, the spectra stayed flat. Independent astronomers began comparing their data across different instruments. The same blank regions appeared again and again. Cyanide lines, which had been prominent before conjunction, were now completely suppressed. Oxygen lines looked muted. The entire optical signature of Atlas seemed drained. Some called it the grey veil. Others said it looked like the body had been coated in something reflective, something designed to conceal. Spectroscopy is the fingerprint of the universe. Every element leaves its mark, a pattern of light and shadow that reveals its composition. When those marks vanish, the implication is not absence but transformation. It suggested that 3IATLAS had changed at the atomic level, while hidden behind the sun. What could have altered it so completely in such a short time? One theory proposed that solar radiation had charred the surface, forming a carbon crust that absorbed color. Another claimed that volatile materials had been exhausted, leaving only mineral residue that reflected light evenly. But neither explanation fit the suddenness of the change. The timing was too sharp, and the transition too exact. The color loss began precisely as the object crossed a region of increased solar activity. A small coronal flare erupted just hours before Atlas became visible again. Some astrophysicists now wonder if that event bathed the object in a burst of high-energy particles strong enough to restructure its surface. That kind of bombardment could strip molecules apart, melting ice into carbon and silicate glass. Yet the pattern of suppression looked too selective. Cyanide disappeared almost completely, but traces of methane and carbon monoxide survived. In a private observatory forum, a retired chemist posted a different idea. He noted that some compounds can hide spectral lines if they form metallic clusters. If 3IATLAS's surface bonded into a lattice of complex molecules, it could act like a mirror, blending colors into a neutral tone. Essentially, the object could have cloaked its chemistry. Whether by natural reaction or something more unusual, it had erased its chemical voice. Meanwhile, NASA's official portal released only filtered light curves, omitting the detailed spectra entirely. Independent data showed faint irregularities that might indicate selective reflection, but the absence of official confirmation left the mystery hanging. Some observers asked why a supposedly normal comet had suddenly become classified under a restricted data tag. When the European Southern Observatory quietly published a follow-up report weeks later, one line stood out. It mentioned an unresolved inconsistency in the cyanide band between 380 and 390 nanometers. That was all. No explanation, no hypothesis, no comparison chart. Just acknowledgement that the data did not fit. To those who study comets, color means life, volatile motion, chemistry, evolution. Losing it means something essential is stopped. But what if the loss was not decay, but adaptation? What if Atlas was responding to radiation, not by dying, but by evolving? The surface temperature of Atlas at re-emergence was measured to be lower than expected despite its proximity to the Sun. That contradiction could mean an insulating layer had formed, perhaps from compounds that reorganize themselves when struck by solar heat. Such a layer could absorb dangerous wavelengths and reflect the rest. It would explain the muted tones, the silver-grey appearance reported by optical trackers. Yet this would also suggest an advanced natural defense. a system more complex than a frozen chunk of rock should possess. It would mean 3IATLAS had the ability to regulate its exposure, adjusting to solar intensity in real time. Some compared it to how certain minerals on Earth undergo photo-darkening, changing color when light levels shift, then reverting later. The key difference is that Atlas's change seems irreversible. Once grey, always grey. There is another possibility one few speak about openly. Some think the color loss marks an internal shift. If Atlas contained trapped gases that were slowly released, the remaining shell could be hollow, with light bouncing inside like a resonant chamber. That would blur spectral lines and flatten its color. It would also mean the comet is no longer solid, but more like a vessel, a shell of mineral glass wrapped around emptiness. Radio instruments scanning the same region reported faint polarization anomalies. That kind of distortion often occurs when light passes through magnetized dust or plasma. Could the missing color be the effect of a new electromagnetic field around the object? If Atlas carried a magnetic halo, it could polarize sunlight, filtering out certain wavelengths before they reached our detectors. That would create the illusion of missing chemistry, when in reality the light was twisted, not gone. This theory gained traction after a small burst of polarized radio noise was recorded by one of NASA's listening stations. The timing matched the comet's reappearance almost exactly. But rather than investigate the connection, the event was labeled unrelated interference. The raw recordings were not made public. As days passed, the muted glow persisted. Ground telescopes captured images of Atlas glowing softly against the dark background of space. No tail shimmered, no cyanide green band curled behind it, only a cold grey aura. The object seemed stripped of character, yet somehow more controlled, as if the wild chemistry of its earlier days had been tamed or suppressed. Some astrophysicists began calling this phase the neutral state. They speculated that Atlas might alternate between chemical and neutral phases as it travels through varying radiation environments. It might be a kind of survival response, allowing the object to preserve volatile compounds by sealing them under a hard, reflective crust. But the human mind always leans toward mystery. The absence of data feels louder than presence. Why would an interstellar traveler hide its true color upon entering our view again? What could it be avoiding? Curious note appeared on one astronomy board from an anonymous user claiming to have access to raw European data. The post included a snippet of spectrum showing a narrow peak at a wavelength associated with ionized nickel. That line should not appear in a neutral grey body. Nickel emission implies heat, perhaps from an internal energy source. If that image was genuine, then Atlas had not gone dark. It had simply changed its method of shining. In ancient times, color was thought to be the soul of light. When color vanishes, something fundamental is missing. For astronomers, it is not just aesthetics. It is information, the story written in photons. When that story goes blank, the imagination fills the silence. Today, Atlas drifts farther from the sun, fading again into the night. Its grayness remains unexplained, its spectrum half empty, its chemistry uncertain. Perhaps it is merely a relic of interstellar dust scorched into silence. Or perhaps it carries within it a process we have yet to name, one that can rewrite matter under the heat of a star. Either way, the color we are not seeing may be the most revealing clue of all. It reminds us that the universe does not always speak in light. Sometimes its greatest message is in what it chooses not to show. When 3IATLAS re-emerged from behind the sun, every telescope that could see that part of the sky was watching. Dozens of instruments were waiting for the first glint of reflected light, the moment when the mysterious interstellar object would come back into view. But something odd happened. The data that should have captured its reappearance were missing. The frames that mattered most, the ones marking the exact second Atlas crossed the solar limb, were gone. At first, it seemed like a coincidence. Solar observatories occasionally experience data loss when radiation storms interfere with transmission. The official explanation cited brief telemetry disruptions, nothing unusual. But as observers compared archives, a pattern began to emerge. The missing frames were not random. They all belonged to the same window of time, the very interval when Atlas should have become visible again. In one European dataset, the recording resumed only after a 2-minute gap. The timestamps aligned perfectly with a similar void in NASA's solar and heliospheric observatory stream. Independent observatories in Chile and Hawaii found their own small gaps as well. Some were seconds long, others minutes. It was as though every eye in the solar system blinked at once. When scientists tried to fill those gaps with backup images, they discovered that even mirrored datasets on independent servers lacked those specific moments. That had never happened before. Usually, if one observatory drops frames, another can fill in the blanks. But this time, the blanks remained. The sun was there. The stars were there. Only Atlas was not. The mystery deepened when a handful of amateur astronomers revealed they had captured partial data using smaller telescopes. Their raw images showed faint smears near the expected coordinates. After processing, those smears appeared to curve, not along the predicted trajectory, but at an angle suggesting deflection. It was subtle but distinct. The light trail bent slightly upward, as if Atlas had reacted to something. NASA's explanation remained simple. A temporary calibration delay, they said. A routine artifact. But even with that reasoning, the coincidence was impossible to ignore. The exact minutes lost corresponded with a brief solar flare on the opposite hemisphere of the sun, one too weak to disrupt all observation networks simultaneously. Astrophotographers replayed the observation logs frame by frame. They noticed that before the missing sequence, the solar corona brightened unusually in a small, localized burst. After the gap, the same region appeared darker, almost burned out. The difference in light intensity suggested that something had crossed the field, reflecting sunlight and altering the exposure. Yet the image showing the transition no longer existed. Those who study solar observation know that data gaps can occur for technical reasons: antenna alignment, processing queue errors, or corrupted files. But when those gaps appear across multiple instruments from different countries and agencies, the odds of coincidence collapse. Something had to have been removed or suppressed after the fact. A researcher at an independent data lab in Canada noticed another clue. In the publicly available video feed, the timestamps did not flow continuously. Instead, the seconds jumped backward and forward by small amounts. He described it as stitching, the kind of artifact that occurs when missing frames are replaced with duplicated ones to smooth the playback. It meant that the footage had been edited before release. When questioned, the responsible space agency offered no comment. They simply said the data were undergoing reprocessing. To many, that silence spoke louder than any official statement. Some astronomers proposed a less dramatic explanation. Perhaps Atlas had brightened so suddenly that automatic exposure controls clipped the image, creating a temporary blackout. The detectors could have saturated from the sudden light, forcing a software reset. That theory raised a new question. What could make an object brighten so violently behind the sun? If the outburst was natural, it would require an enormous jet of gas or dust. Yet no debris was visible afterward. If it was not natural, then we were looking at something controlled. The thought was unsettling. A few observers pointed out that the brightness anomaly matched an electromagnetic spike detected by a European solar probe at that same time. The probe recorded a sharp pulse lasting less than a second, too short to register as a flare but strong enough to overload sensors. If Atlas emitted or reflected that burst, it might explain both the missing frames and the altered light afterward. The phrase "skipped moment" began circulating in astronomy forums. People compared the re-emergence of Atlas to a magician's sleight of hand. Everyone was looking, yet the crucial instant vanished in plain sight. An amateur astronomer in Japan tried to reconstruct the gap using pre-gap and post-gap frames. When he overlaid them, he noticed that background stars had shifted slightly relative to the Sun, indicating that the observation interval was longer than the timestamp suggested. In other words, time itself had been trimmed from the record. Whether by error or intent, those minutes had been erased. The missing sequence might have gone unnoticed if not for a peculiar side effect. During that same time, instruments on Earth registered faint increases in magnetic field strength, tiny ripples that did not match normal solar activity. Some speculated that if Atlas interacted electromagnetically with the solar environment, it could have caused a brief localized disturbance. That might explain the faint, coronal flicker and the delayed resumption of data transmission. Yet others found the timing too perfect. The world's observatories had prepared for this exact reappearance for months. The idea that every instrument failed in unison was statistically impossible. One astrophysicist compared it to all security cameras in a building shutting off the moment something crosses the hallway. It was not the first time a celestial event had coincided with selective data loss. In past years, astronomers had reported brief gaps during high-profile meteor detections, planetary transits, and even asteroid flybys. Usually these were dismissed as coincidence, but the precision of Atlas's missing frames stood out. The object's entry and exit times were exact, and the loss occurred right in between. This led to an unsettling hypothesis. What if the data had not been lost, but withheld? Because if the raw images still existed somewhere, then someone decided the world should not see them. One anonymous engineer claimed on a private astronomy forum that internal logs showed successful data capture, but that the files were later flagged for review. The reason given was excessive reflection anomaly. He said the term was new to him. The post vanished within hours, and his account disappeared soon after. If true, that phrase hints at something strange. Excessive reflection could mean a sudden increase in brightness beyond the expected albedo of a comet's surface, perhaps light bouncing off an artificial shape, something smooth and geometric. If Atlas's reappearance was accompanied by a reflective flare, it would explain the missing frames. The overexposure could have revealed something that instruments were not meant to capture. As speculation spread, agencies began releasing carefully worded updates, insisting that all systems were functioning normally and that no anomalies were present. But those reassurances came without the raw data. The same blank interval remained in every public archive. Months later, when new analyses were published, a quiet detail surfaced. The missing frames corresponded to a point in the object's trajectory when it should have been closest to the Sun's magnetic boundary line. This zone, known as the heliospheric current sheet, is a region of intense electromagnetic interaction. If Atlas passed through it, it could have generated a plasma discharge bright enough to blind sensors temporarily. But the lack of even one recovered image made it difficult to confirm. Whether by cosmic chance or deliberate omission, the skipped frames created a perfect void. A single heartbeat in the universe's timeline where something extraordinary might have happened, and no one could prove it. In the end, all we know is that the story of Atlas's return is incomplete. The data trail has a hole in it, a missing sentence in a cosmic paragraph. And like all mysteries, what is hidden becomes more powerful than what is shown. Because sometimes the truth is not in the frames we see. It is in the ones that never reach us at all. When the first clear images of 3IATLAS after its re-emergence appeared, astronomers expected to see a predictable sight. A thin, sunlit stream of gas and dust stretching neatly away from the solar wind, glowing faintly in the darkness. That is how comet tails behave. They follow the pressure of light and charged particles like smoke in a breeze. But Atlas refused to obey that rule. Its tail bent the wrong way. Not once, but several times over the course of a single night. Observers from multiple continents recorded the same baffling pattern. At first, the tail pointed directly away from the sun, then slowly began to twist. By midnight, it was angled almost perpendicular to its predicted path. Then it shifted again, as though responding to something invisible. Astronomers attempted to explain the movement as a projection effect. They said the apparent motion could be caused by changes in viewing angle or the rotation of the nucleus. But as more data poured in, the rotation theory collapsed. The curve of the tail moved faster than the body itself could spin. It was as if the tail had its own consciousness, reacting independently of the object that produced it. High-resolution imagery from one observatory in Chile revealed something even stranger. The tail appeared to ripple, forming waves that traveled outward, as if pulsed by an unseen rhythm. Those waves were evenly spaced, almost mechanical. Comets can produce waves through bursts of outgassing, but these were too uniform. It looked less like random jets and more like deliberate coordination. When scientists compared the ripples to radio data from the same period, they found faint magnetic fluctuations at matching intervals. The synchronization was uncanny. Every pulse of light in the tail lined up with a change in the surrounding solar magnetic field. That connection led some researchers to suggest that Atlas might be generating its own electromagnetic response, interacting with solar plasma in ways we have never documented before. If that were true, then Atlas was not a passive traveler. It was an active participant in its environment. NASA released a brief statement saying the orientation of the tail was due to complex solar wind variations. It sounded reassuring, but the explanation did not hold up. The solar wind during that window had been steady. No recorded storm, no coronal mass ejection, no flux change large enough to cause such erratic motion. Something else was at play. Amateur astronomers created time-lapse sequences from their observations. When those clips were stitched together, the tail seemed to twitch like a living thing. It extended, retracted, and then swept sideways, leaving behind faint trails that looked like brush strokes on black canvas. The motion was too precise to be random. In some frames, the tip of the tail traced a near-perfect arc before halting abruptly. One researcher described it as a marionette responding to invisible strings. Another said it behaved like a compass needle that could not decide which magnetic pole to follow. During one particularly bright observation window, instruments detected a secondary filament branching off the main tail. Instead of dispersing, this filament maintained shape, moving in parallel as if tethered. It glowed faintly blue, suggesting ionized gas, but its stability was unheard of. Ion tails usually fluctuate wildly under solar pressure, yet this one held firm, almost defiant. If Atlas had been a single, solid object, such precision would be impossible. But if it possessed internal magnetism or layered materials capable of interacting with charged particles, it might explain the coordination. Some scientists began to wonder whether the object was composed of alternating metallic and icy regions. As it rotated through sunlight, those materials could produce varying electromagnetic fields, steering the ionized particles in specific directions. That still did not explain the apparent awareness of timing. The movements occurred in pulses, matching the light rhythm noted earlier in its brightness curve. This recurring synchronization led to the unsettling idea that Atlas might operate on cycles, chemical, magnetic, or something else, governing both its light and its motion. One astrophysicist compared the sequence to biological processes. He noted that some organisms on Earth display rhythmical cycles of energy release, even when isolated from environmental cues. What if Atlas exhibited a similar self-regulating pattern, born not of biology but of physics that borders on the unknown? By the third day of monitoring, the tail's unpredictable motion had drawn global attention. Forums filled with theories. Some claimed it was the first recorded case of a magnetically guided comet, one able to navigate through solar currents like a sailboat using shifting winds. Others took a bolder stance, suggesting the object was responding to something external, perhaps signals from solar radiation bursts or other celestial fields. The strangest twist came when instruments detected that the tail's angle oscillations corresponded almost exactly with fluctuations in Earth's magnetosphere. The link was weak but measurable. Every time the tail swayed, our planet's magnetic field showed a minor pulse. The idea that a body millions of kilometers away could echo effects on Earth seemed absurd, yet the numbers aligned. If coincidence, it was a profound one. If connection, it meant that whatever influenced Atlas might reach far beyond its own orbit. In official channels, updates grew scarce. Observatories that had been releasing hourly data switched to summary reports. The real-time feeds went offline for maintenance. For a time, the only updates came from amateur trackers who shared their grainy images online. Their pictures showed the tail continuing its erratic dance, curling and twisting like a strand of light caught in invisible turbulence. One observer from Argentina captured something remarkable. For a brief interval, the tail appeared to fold inward, forming a spiral. The spiral glowed faintly before unraveling into a thin plume that shot directly sunward, the opposite direction of all known cometary physics. A tail moving toward the sun should not exist. Solar pressure should immediately force it back. Yet in that moment it held its course. When scientists examined the sequence, they called it an imaging illusion. But even those who said so could not hide their astonishment. The spiral movement was clear, repeating twice before dissipating. It gave the eerie impression of reaction, as if the object had sensed the growing attention and responded by doing something no one could explain. Weeks later, as Atlas drifted farther from the sun, its tail began to settle. The erratic sweeps grew slower, the angles more stable. Still, faint pulses continued to ripple along its length, fading only when it reached the outer imaging limits of our telescopes. It was as though the object had completed its performance and slipped back into silence. In scientific papers, the event was summarized as a complex interaction between solar wind variability and nucleus outgassing. But behind closed doors, researchers admitted they had never seen a comet behave like this. Some privately called it a self-regulating plasma structure. Others hinted that Atlas might not be a single body at all, but a cluster bound by electromagnetic cohesion. Whatever it was, it demonstrated behavior that mimicked decision. Each adjustment of its tail appeared timed, almost cautious, as if guided by awareness of surrounding forces. Perhaps it was simply nature at its most intricate, a combination of physics so perfect that it seemed alive. Or perhaps it was a sign of something deeper, a cosmic phenomenon that responds, adapts, and evolves within the solar wind itself. The image of that moving tail remains burned into the minds of those who watched it. A slender thread of light twisting through space, turning when no wind turned it, pointing where no rules said it should point. A motion that felt less like chaos and more like intention. In that quiet defiance, 3IATLAS reminded the world of a truth we often forget. The universe does not always behave as we expect. Sometimes it moves with purpose we cannot yet measure. Sometimes even a trail of dust can seem to think. When the first detailed images of 3IATLAS's Re-emergence were released, astronomers believed they were looking at the same irregular, uneven structure that comets usually display. But as higher resolution photos came through, something began to disturb the scientists who studied them. Beneath the haze of dust and ionized gas, subtle geometric formations appeared, patterns that seemed too deliberate, too consistent to be random. At first, the geometry showed itself faintly, like ghost lines beneath fog. Bright jets from the nucleus emerged not from random fissures, but from locations spaced at even intervals. Each jet seemed to erupt along a straight path, and when plotted, those paths formed a near-perfect triangular symmetry. In nature, that kind of alignment rarely happens by chance. Comets are chaotic. Their surfaces fracture unpredictably, venting gas where sunlight strikes weakest crusts. But Atlas appeared engineered by precision. Astronomers tried to dismiss the pattern as coincidence, perhaps the effect of light scattering through uneven dust clouds. Yet as the object continued to rotate, the angles held. They did not drift or distort as lighting changed. When the nucleus turned, the same geometric relationship between its outflows stayed intact. It was as if Atlas carried a blueprint, a design that persisted no matter its orientation in space. When the images were enhanced using polarized light filters, more details emerged. The jets traced not only triangles but also faint circular arcs that intersected at mathematically consistent points. The ratio of distance between those intersections approximated constants found in crystalline structures. It was like looking at a natural polyhedron made of energy and dust. Some observers called it the lattice. Others simply said, "This is not what a comet looks like." The symmetry grew even more suspicious when the data from radar imaging were analyzed. The reflected signals returned in timed echoes that suggested flat planes or smooth surfaces. Comets normally scatter radar waves unevenly because of their rough, porous textures. Atlas, however, reflected back as if parts of it were polished. One researcher described it as seeing geometry within chaos. When independent scientists attempted to replicate the analysis, they encountered something curious. The official image sets had changed. The later versions released through public databases were smoothed out, their fine geometric details blurred. The earlier images, however, had already circulated through amateur networks. In those unaltered frames, the angles were clear. Some began to compare the geometry to earlier mysteries in astronomy, such as the hexagonal storm on Saturn's pole, another naturally occurring yet highly symmetrical formation. But Saturn's hexagon has an explanation grounded in atmospheric waves. Atlas's geometry existed in the vacuum of space, where no wind, no pressure, no turbulence could sculpt shapes that precise. The simplest explanation was rotation. Perhaps the object spun rapidly, causing evenly timed ejections of gas that created the illusion of geometry. Yet the rotational speed measured by photometric data did not support that theory. The nucleus rotated too slowly to produce such frequent symmetric outflows. That left only two possibilities. The geometry was the product of internal structure or of something interacting with the object externally. A few researchers speculated that Atlas's surface contained regions of varying conductivity. If metallic compounds were embedded in the crust, they could channel solar energy along fixed pathways, creating predictable eruption points. But this explanation raised another question. How could an interstellar body accumulate metallic grids arranged with such regular spacing? The likelihood was almost non-existent. In one of the last unfiltered images released before the object faded again, observers noticed that the geometric arrangement extended beyond the nucleus. The tail itself appeared segmented, its brightness intensifying at intervals that matched the spacing of the jets. When connected, those points formed repeating triangles stretching outward into space. The pattern looked deliberate, like geometry expanding into infinity. A mathematician studying the sequence found that the distances between those luminous nodes followed a near-perfect Fibonacci progression. It was not exact, but close enough to suggest a self-organizing process. This discovery changed everything. A Fibonacci pattern is a natural signature of growth and harmony, often found in biological and crystalline forms. To see it emerge in a comet's tail defied every known physical model. If this was natural, then nature had just shown a new way of building order out of chaos. But if it was not natural, then 3IATLAS might be carrying something, some internal architecture that followed universal mathematical principles for reasons we could not yet understand. NASA's public commentary avoided specifics, referring to the symmetry as optical coincidence. Yet leaked technical notes from an observatory mentioned periodic dust ejecta, forming coherent angular geometry. Those words hinted that even within official channels, scientists saw more than coincidence. They saw intention written in physics. The geometry seemed to pulse in rhythm with Atlas's periodic brightness changes. Every time the object brightened, the jets aligned more sharply, glowing in sequence like lights along a frame. When it dimmed, they faded together. That coordination suggested a single controlling mechanism. But what could control a body that drifts freely through the void? Some proposed that resonance could be the key. If the object carried trapped gases in layered cavities, solar radiation might excite them at specific frequencies, causing pressure releases in symmetrical intervals. That would mean Atlas's interior functioned like a natural harmonic oscillator, a cosmic instrument tuned by light itself. Others saw something more deliberate. In private discussions, a few researchers admitted the geometry resembled engineered arrays like antenna alignments or structural panels. The radar reflection supported that idea, showing flat surfaces where randomness should reign. Still, most dismissed such thoughts as speculation, insisting that nature often mimics order when conditions align just right. Yet deep in those observations, a more profound question emerged. What if geometry itself is not a sign of design, but of consciousness built into the universe? What if symmetry is how matter remembers the rules that shaped it? As Atlas drifted farther from the sun, the geometry softened. The sharp lines blurred into haze, and the object began to look ordinary again. But the memory of those patterns lingered. They had been captured in data, in light curves, in spectral signatures. The geometry did not vanish, it simply became harder to see. Months later, when new images from different observatories were compared, faint traces of that same triangular alignment reappeared. Even as the object dimmed into deep space, the geometry persisted like a fingerprint burned into light itself. Some skeptics argued that humans see patterns where none exist. They called it pareidolia, the brain's desire to find structure in noise. But that explanation failed to satisfy those who had measured the geometry directly, those who had seen the math align too neatly to be imagined. One scientist described it best in a closed symposium. He said, "If geometry arises where chaos should reign, then we are not looking at coincidence. We are looking at communication." His words were met with silence. Maybe Atlas was not sending a message. Maybe it was the message, a shape moving through darkness, built upon numbers older than stars. A geometry that should not be there, yet was. The universe speaks in form and ratio long before it speaks in words. And sometimes, when we look closely enough, we see that message written across the sky, not in the light we expect, but in the order that refuses to fade. Atlas carried that order, if only for a moment. A fleeting, perfect geometry that glowed against the blackness, reminding us that even the coldest traveler from another star can bear the mark of something greater. Something that builds shape where there should be none, and pattern where there should only be dust. It began as a coincidence too small to notice. A few moments of silence in a single observatory feed, an unexplained drop in telemetry, a minor pause in data streaming from one of NASA's probes. But when the timelines were compared, the silence lined up. Every major instrument observing 3IATLAS during its solar re-emergence, space-based, ground-based, and even independent radio networks had gone quiet at exactly the same moment. No alerts had been issued, no warnings of system resets or solar interference. The instruments simply stopped reporting, as if someone had pressed mute across the sky. The gap lasted only minutes. Yet in the world of continuous observation, even seconds matter. Those missing moments corresponded perfectly to the time frame when Atlas should have been most visible, moving away from the solar limb and entering the open field of view. The odds of such synchronized silence were astronomical. NASA's explanation was short. It was a routine data backlog, they said, caused by transmission congestion between observatories. But the independent logs told another story. The timestamps were not staggered as they would be in a backlog. They were aligned to the second. Solar observatories in Hawaii, Chile, and Europe all recorded their own local pauses. Radio antennas pointed at the sun's corona registered a sudden flattening of signal, as though an invisible hand had covered their ears. Even instruments not directly observing the sun, planetary magnetometers, atmospheric sensors, low-orbit satellites, showed faint interruptions. If it had been a solar storm, the noise would have spiked. Instead, the universe fell silent. The event left no damage. Systems came back online without faults or errors. It was as though nothing had happened, yet something had. In the hours that followed, telemetry analysts noticed residual interference patterns buried deep in the background data. The readings resembled static, but not the random kind. They pulsed. The rhythm matched earlier fluctuations recorded in the light of Atlas itself. One scientist described it as a fingerprint of silence, a structured absence, as if the instruments had received too much information all at once and stopped to process it. Rumors began to spread in observatory circles. Some claimed the sensors had been deliberately switched off. Others whispered that the instruments had not gone silent. They had been overwhelmed. A few even speculated that the object had emitted something beyond standard measurement, something that caused every sensor tuned to it to freeze. When technicians reviewed satellite diagnostics, they found no errors in power or data flow. Yet the signal gaps showed signs of compression artifacts. That meant the data had been replaced, not lost. It looked like a smooth transition between valid readings, except the timestamps revealed the truth. The silence had been edited in. NASA denied any data tampering, but a few engineers leaked fragments of their internal logs. Those logs showed that during the blackout, 3 of the most advanced instruments, the Solar Orbiter, the Parker Solar Probe, and the European Solar Dynamics Array, had all entered a safe mode simultaneously. Each had different software, different triggers, and different thresholds. For all 3 to activate together would require either a shared external shock or a coordinated command. No command was issued. This revelation raised a chilling possibility. Something external had touched them. Something with the ability to trigger a protective reaction across multiple systems designed by different nations. If Atlas emitted an electromagnetic pulse or a burst of charged particles, it could in theory cause such reactions. But the instruments that went silent were shielded against that kind of interference. They had weathered stronger solar events before without a hiccup. This was not energy overload. It was communication, an impulse that seemed to say, stop. The silence spread beyond hardware. Around that same time, ground-based monitoring stations tracking geomagnetic activity reported an unexplained stillness in the Earth's ionosphere. Usually solar activity creates gentle oscillations, but during those few minutes the readings went perfectly flat. Even natural background noise disappeared. The entire electromagnetic environment of the near-Earth region had paused. Scientists could not recall another instance when so many systems across so many frequencies aligned into one unified hush. When the instruments came back online, their first images showed Atlas already moving outward, its brightness slightly higher than before. But the data that should have covered its exact transition remained blank. Analysts pieced together what little they could from secondary sensors, and what emerged was disturbing. The magnetic field around Atlas appeared to have expanded dramatically during the silence, almost as if it had inflated and then collapsed. This led to a new theory, that the blackout had not been a failure at all, but an interaction. The object's electromagnetic field might have briefly synchronized with Earth's, creating resonance that caused instruments to misread reality. If the frequencies matched perfectly, sensors could interpret the flood of coherent data as zero, a paradox of signal overload that manifests as silence. If true, it would mean that Atlas temporarily tuned the solar system around it. When word of this hypothesis spread, agencies grew cautious. Reports were rewritten, graphs were rescaled to hide alignment timestamps. Some scientists were reassigned. Officially, the blackout became a cross-calibration event, but those who had seen the raw data knew better. A small team of researchers from Japan and Sweden independently reconstructed parts of the signal. They found that the background static during the silence contained faint modulations, patterns too structured to be random noise. When converted to audio frequencies, the signal produced a slow, rising hum that repeated 3 times before cutting off. The scientists called it the tone. The tone was short-lived, but it carried information. Its frequency ratio matched no known solar or planetary harmonic. One physicist described it as the electromagnetic equivalent of an echo bouncing off nothing. If Atlas had emitted it, then it was not just reflecting sunlight, it was broadcasting something else entirely. Still, without the original sensor data, no one could confirm it. The agencies controlling those instruments refused to release the full logs. They said the missing minutes were unimportant, that the equipment had simply recalibrated. But in the world of astrophysics, calibration does not happen in perfect unison across independent systems. Some began to wonder if the silence itself was the message. If you wanted to hide a signal, the best way would be to stop all receivers at the exact moment it was transmitted. A burst strong enough to trigger safety protocols could ensure no one captured the original waveform. What if Atlas released such a burst, not destructive, but commanding? A whisper written in magnetism, forcing every machine that heard it to turn away. It is an unsettling thought. Machines react to instruction, not emotion. For them to shut down together means they recognized something universal, a condition, a pattern, a command that overrode their differences. After the event, solar data streams resumed their usual rhythm. The world moved on. But deep within the archives, the silence remained, encoded as a gap that should not exist. Some say that if you line up those silent minutes from every observatory and play them together, a faint pulse still beats through the emptiness. Perhaps it is nothing. Perhaps it is only data loss, a glitch in the harmony of cosmic observation. Or perhaps it is the echo of something greater, an object from another star reminding our instruments. And us, that silence can sometimes be louder than any signal, and somewhere beyond the sun, 3IATLAS continues its journey quiet once more. Whether it caused that hush or merely passed through it, the result is the same. For a brief moment, the entire watchful sky forgot how to speak. It began with a flicker in the sun, a sudden surge of magnetic energy, barely visible to the naked eye but recorded by solar monitors with perfect precision. Just as 3IATLAS emerged from behind the solar glare, a coronal disturbance rippled across the sun's surface, spreading outward like the echo of a heartbeat. The two events happened within minutes of each other. To scientists, timing is everything, and in this case, the timing was impossible to ignore. Solar storms occur constantly, but their alignment with deep space objects is rare. The flare that erupted at that moment was minor, barely registering as a C-class event on the solar scale. Yet it appeared directly in line with the coordinates where Atlas had just reappeared. It was as if the sun itself responded to the object's return. NASA's report framed it as coincidence, a matter of overlapping data. But independent researchers noticed something strange about the disturbance. It did not radiate in the typical circular pattern. Instead, it stretched along a narrow line like a beam, pointing outward toward the region of space where Atlas was located. Even stranger, magnetometer readings from the solar orbiter showed the wave arriving earlier than predicted, suggesting that the sun's magnetic field had reacted before the flare became visible. This reversal of cause and effect raised eyebrows. Normally, energy travels outward from the sun to the heliosphere, but in this case, the data implied a push from the other direction, as if something external had disturbed the sun first. If true, that would be unprecedented. No comet, asteroid, or interstellar visitor has ever influenced solar activity in measurable ways. Yet here was a disturbance matching Atlas's reappearance to the second. The moment it stepped out of the sun's shadow, the sun itself rippled. When solar physicists examined the magnetogram footage, they noticed something subtle. The flare began not at a random point on the surface, but exactly at the border of a coronal hole, one of the massive open regions where the sun's magnetic field lines extend into space. That same hole had been stable for weeks. Its sudden activation seemed spontaneous. The wave that followed carried a faint spiral motion, twisting through the corona like a corkscrew. The shape of that twist matched the rotation of Atlas's magnetic tail recorded earlier. The correlation was more than visual. Instruments tracking solar radio frequencies picked up a series of short bursts moments before the flare. Each pulse mirrored the rhythmic pattern of brightness fluctuations seen in Atlas days prior. It was as though the object and the star had entered a kind of magnetic dialogue. Mainstream science avoids such language. Stars do not talk to comets. But the mathematics did not care about interpretation. The timing aligned too perfectly. As the flare traveled outward, solar wind particles streamed past the path of Atlas. And something unexpected happened. Instead of dispersing in a uniform pattern, the plasma curved, forming a narrow sheath around the object. The field lines bent toward it as though drawn by gravity, though the effect was electromagnetic. The object was not being pushed by the wind, it was interacting with it, shaping its own corridor through the solar current. The behavior resembled the way a planet's magnetosphere diverts charged particles, creating auroras. But Atlas was too small to generate such a field, at least according to known physics. To bend plasma at that scale would require a magnetic strength thousands of times greater than any comet ever measured. Either the numbers were wrong or something extraordinary was happening. Observers began to notice faint waves propagating through the tail of Atlas at the same rhythm as the sun's disturbance. The object seemed to pulse in harmony with the solar wind, brightening slightly every time the wavefront reached it. This synchrony persisted for several hours before fading. One researcher described it as resonance across distance. The idea was that both the Sun and Atlas were oscillating within the same electromagnetic field, locked in temporary synchronization. He compared it to two tuning forks vibrating at the same frequency across a room. When one is struck, the other begins to hum. But what had struck first? The Sun, or the traveler days later, when the flare's effects reached Earth, geomagnetic sensors recorded a brief, sharp pulse, followed by a lull. During that lull, Schumann resonance monitors, the instruments that track the Earth's natural electromagnetic heartbeat, registered a deviation. The planet's frequency dipped by a fraction, then rebounded, mirroring the same rhythm seen in Atlas's tail. The connection was faint, but it extended across the solar system. To some it was coincidence, stacked upon coincidence. To others it felt like pattern. The Sun had stirred when Atlas appeared. The Earth had quivered in response. And between them hung a single object of interstellar origin that behaved like a conductor between two cosmic instruments. NASA maintained its cautious stance, labeling the event an interesting temporal overlap. But in the quiet corners of online forums and research groups, speculation deepened. What if Atlas carried material capable of resonating with solar frequencies, crystals or metallic compounds that absorbed and re-emitted electromagnetic energy? Could such material trigger feedback within the solar magnetic field? The answer, at least in theory, was yes. Certain crystalline structures can amplify oscillations under magnetic stress, a phenomenon known as magnetoelastic coupling. If Atlas contained such compounds, its interaction with the Sun might have produced resonance visible across millions of kilometers. In one paper that never reached peer review, an astrophysicist proposed that Atlas was not reflecting sunlight at all, but rather re-radiating it after modulation. According to his model, the object's changing brightness could encode frequencies that interact with solar fields. In effect, Atlas was humming along with the Sun. As more data emerged, a new detail surfaced. During the synchrony event, the solar wind speed briefly dropped before surging again. It was as if the flow of charged particles encountered resistance. The pressure curve looked like something had absorbed part of the stream, then released it. No known natural object could do that so cleanly. Some observers wondered whether Atlas had acted as a magnetic lens, focusing solar energy instead of deflecting it. That would mean it was not merely reacting to the disturbance, it was shaping it. If so, the flare might not have been a coincidence at all. It might have been a response. There was one final piece of the puzzle. A probe studying solar radiation detected a faint ultraviolet flash in the same line of sight as Atlas roughly 1 second after the flare. The intensity was weak, but its spectrum did not match sunlight. It bore the signature of ionized nickel, the same element previously detected in the comet's composition, an element that should not glow at those wavelengths unless excited by direct energy transfer. It was as though Atlas had reflected the flare's energy back toward the sun, briefly closing a circuit across space. Afterward, everything quieted. The flare faded, the solar wind normalized, and Atlas drifted farther away. But when scientists looked back at the recordings, they realized something chilling. The timing between each solar pulse and each brightening of Atlas formed a perfect mathematical progression. It was not random. It followed ratio and rhythm, a pattern repeating with precision, too sharp for natural turbulence. That was the moment the phrase solar synchrony entered the conversation. It described a relationship that should not exist, a dance between a star and an interstellar wanderer bound by invisible resonance. Perhaps it was only coincidence magnified by imagination. Or perhaps for one brief moment, something alien in its structure had found harmony with our sun, singing back a note that rippled through space and touched every magnet. Every field, every planet listening, whatever the truth. The data remains. On the graphs of that day, two curves rise and fall together, like twin pulses in one cosmic heartbeat. The sun flared. Atlas answered. And the silence that followed was not emptiness. It was the echo of a connection that defied everything we thought we knew about how the universe communicates with itself.